accommodation, part of the GCSE bio course. Now, this is a concept that I struggled to understand. It was quite confusing and I didn't really understand the terms that were in it and like the entire concept itself. But after studying it for a couple of hours, I finally understood how to memorize it and how to actually understand what's happening without just memorizing a table. All right, before we get into what accommodation is, we first need to know what the purpose of it is. So it's to help us focus on close and distant objects. So our eyes can't focus on both close and distant at the same time. So the lens that refracts the light in order to hit the retina needs to change in order to ensure that the light hits the retina properly, and therefore a blurry image is not created. And by the way, the fovea is just the most sensitive part of the retina. So if we draw a quick cross-section diagram of an eye, the object is here. By the way, this cross-section means side view. Okay, so that's the front of the eye, like our face. So this is the part of the eye that we see, and this is just the side of the eye that's inside our body. Okay, so we have the lens like so. Now these are all the important terms that we need to know. Lens, and here we have the retina. And at the center of it, more or less the center, is the fovea, which is the most sensitive part. Now we have two more things: ciliary muscles and suspensory ligaments. Suspensory ligaments are like so. These are the suspensory ligaments. And the ciliary muscles are like so. These are the ciliary muscles. Ciliary muscles, suspensory ligaments. Pretty easy up to here, right? Okay, so we do need to understand this. For close objects, we need to refract light quite strongly. And for distant objects, the light needs to be refracted weaker. Okay? So close objects, so here's another drawing of an eye. If we have close objects, we need to refract this light strong. And for distant objects, weak. That is pretty much the entire concept of accommodation. Now we need to understand how this concept actually works. All right, so this is how this works: close and distant objects. Here's a cross-sectional diagram again, side view. Okay, now this is the part that I struggle to understand the most, but I'm hoping that if you guys just watch this video, you'll be able to understand, because this really helped me understand. Okay, cross-section, right? So we need to refract light strong. Close objects are refract light. Light, I can't speak right now. Light is refracted strongly, and for distant objects, weaker. Okay? Okay, so take a look at the cross-section. Now, this is a really simple and easy way to understand this, okay? Close objects are strong, right? So just imagine that the ciliary muscles and the suspensory ligaments, right? These are the two important things. Everything just moves inwards. Close to the lens. Just think about it. Close means strong, and everything just moves closer inwards, right? So this is the concept that really confused me. Ciliary muscles contract. Usually contract would mean like getting smaller. But here, the ciliary muscles get bigger. They don't really necessarily get bigger, but they get closer. You see, this is for distant objects. It's that's less protruding, and here it's protruding a lot more. So in this sense, the ciliary muscles contract inwards. They push themselves inwards. So you don't necessarily have to add this, like say this in your exams, but I find it really easy to memorize, and you can just say it. Ciliary muscles contract inwards, right? And the suspensory ligaments, if these muscles that are holding the suspensory ligaments are coming in closer to you, would you become tighter or slacken? You'd slacken, right? Because you have a lot less room, but the length of the suspensory ligaments equal. So it becomes slackened, right? Suspensory ligaments slacken and the ciliary muscles contract, right? Everything moves inwards. So this means if these ligaments are slackened, remember these aren't muscles, so you can't say suspensory ligaments relax. Suspensory ligaments, you can't say they relax, they have to tighten or slacken. And in the same way, ciliary muscles, they are muscles, so they contract and relax. Don't get these terms mixed up. This is one of the things that you need to know. So if these ligaments are slackened, it means they aren't pulling on the lens anymore, right? So this means they can be in their natural fat shape to refract light strongly. They are in their natural fat shape because they aren't being pulled, right? So they're going to be fat, right? Because if you're fat but you're getting pulled, you're going to become thin, like for distant objects, but for close objects, you aren't being pulled, so you're going to become fat. And this allows the light to be refracted more strongly. Now this is the front view. Now these diagrams can get quite confusing, but you can imagine this front view is basically what you would see if you were standing right here. Okay, front view. This is part of like an eye, and then this is like the colored bit of the eye that we see in our face, and this is basically this front view if we were standing right there inside of our eye. It's a bit confusing, but I hope that makes sense. All right, front view. This is the lens, right? Now here and this, it kind of looks confusing, right? Because here it looks like the lens is bigger, and here the lens is bigger here. It looks like they're mismatched, right? But the key thing to know is that this is a cross-section view. We said that the lens is in its fat shape, right? Now if the lens is quite fat, right? The front section, this bit is small. As you can see, this bit is quite thin. And here, when the distant objects, the lens is stretched, we can see that this bit is quite a bit bigger. So this is the bit that we're seeing in our front view. And this is the bit, the quite thin and small bit, the front bit that we're seeing. All right? It's actually fatter, but it's not fatter in the sense that the front is fatter. All right? So the lens is going to be basically, it's a bit confusing, right? So the lens is going to be smaller. And these are the suspensory ligaments. This kind of helps you visualize. Just ignore this lens. Just think about this bit. The suspensory ligaments are slackened. They aren't being pulled on anymore. And the ciliary muscles that are surrounding the suspensory ligaments, they have contracted inwards. All of these have moved inwards. So this slackened suspensory ligaments, they are bigger, and now basically they have contracted inwards. Now it's basically just the opposite for distant objects. Cross-section view again. The ciliary muscles relax. They have relaxed outwards. I find it really helpful to use outwards and inwards, because otherwise you can get these terms really mixed up. But these ciliary muscles have relaxed outwards, right? That means the suspensory ligaments that are connected, if this muscle moves outwards, then these ligaments must also move outwards, right? And that means these suspensory ligaments have tightened. If these are tightened, then the lens is going to get pulled, right? It gets stretched thin by these suspensory ligaments, and this causes a weaker refraction. We can kind of see this in the front section. Again, remember, we're looking at it from here. The front view. This is the lens. This is the ciliary muscles. They have contracted outwards. And these suspensory ligaments have also contracted outwards, resulting in the lens being pulled thin. All right. Now, I know that can be quite a bit confusing to remember. So here's a really simple way to kind of think about it. You can think of the suspensory ligaments as the rope, and you can think of the ciliary muscles as the arms. Now this, I know you guys might be wondering, what on earth are you talking about? Okay, let me explain, okay? We have suspensory ligaments, these are the ropes. And these ciliary muscles, these are the arms. Because think about it, these ligaments, okay, if I draw a quick sketch here, and the lens is here, and we have ligaments, and we have the ciliary muscles like so. These ligaments look like ropes, right? So just imagine them as ropes. The suspensory ligaments are ropes, and these slacken and tighten, right? You can't say that ropes contract and relax. They slacken and tighten. Just imagine, just think about them as ropes. Suspensory ligaments are the ropes that hold the lens together, and these can slacken and tighten. In the same sense, ciliary muscles, they are muscles, right? Just imagine them as the arms that are pulling on these suspensory ligaments, the ropes, the arms that pull on the ropes. So these arms, we have muscles, right? Our muscles can contract and relax, right? Our muscles contract inwards and relax outwards. That is pretty much how I would remember it. I hope that helped. And if you have any questions, do leave them down below. Now, I just wanted to end with a quick exam style question on how you would answer them. All right? So we have, okay, here. Describe the changes that happen in the eye when focusing on a distant object. When focusing on a distant object, the lens doesn't need to refract light as strongly as it would for close objects. Therefore, the lens needs to be thin to refract less intensively. To accomplish this, the ciliary muscles relax outwards, tightening the suspensory ligaments, resulting in the lens being stretched thin, thus not refracting as intensively. Close objects. For close objects, the lens needs to be fat and curved to refract light strongly. To do this, the ciliary muscles contract inwards, resulting in the suspensory ligaments slackening. Since the lens isn't being pulled, it returns to its original fat shape, refracting light strongly. And that is accommodation. I hope that helped. And if you enjoyed it, please subscribe and give it a like so that others can see it too. Thank you.